Hey guys, welcome back. So in this video, we're going to talk about absolute values and evaluating limits with absolute values. So this might seem like a tricky concept, but trust me, it's really not too bad if you pay attention as to what needs to be done to solve this sort of questions. So the first thing is, what exactly is the absolute value? So for example, if I ask you to find the absolute value of 3, what would this be? So the absolute value notation, so the sign of the absolute value is just writing that number and putting these two lines on both sides of the number. So the absolute value of 3 in the simplest terms is the distance you move from 0 to that number in a number line. So in order to get to 3 from 0 in the number line, how many units am I moving? Regardless of whether I'm moving right or left. So I'm moving 1, 2 and 3 units in order to get from 0 to 3 on a number line. So in that case, the absolute value of 3 is just equal to 3. If I ask you to find the absolute value of minus 2, so what would that be? Simple. How many units am I moving to get to minus 2 from 0? So from 0 I'm moving 1 and I'm moving 2 units in order to get to minus 2. So in that case, the absolute value of minus 2 is just 2 because I'm moving 2 units from 0 to get to from 0 in order to get to minus 2. The absolute value in a similar way for minus 10 would be equal to 10. The absolute value of, for example, 2 is just going to equal to 2. So as you may have noticed, the absolute value of any given number is just getting rid of the negative sign. But there is a more general definition of the absolute value, which is very important for you to know. So we say that the absolute value of a given term x is equal to x if x is greater than or equal to 0, or it's equal to minus x if x is less than 0. So this might not be pretty obvious to understand at first, but we'll just go over a couple of examples just so that this makes more sense. So if I were to say to find the absolute value of 5, right, while using this definition over here, how would we do it? So in this case, we know that our x is equal to 5, okay, because we've put 5 in place of x over here. So is 5 greater than equal to 0 or lesser than equal to 0? So it's obvious, right? 5 is greater than or equal to 0. So we are going to be looking into this part of the definition. Okay, so if x is greater than equal to 0, which in this case it is, then the absolute value of that x is just equal to x. So in this case, we know that x equals to 5. So the absolute value of 5 is just going to equal to 5. Okay, now let's say I told you to find the absolute value of minus 5 using the definition. So in this case, we know that our x is equal to minus 5 because we plugged in minus 5 in place of x over here. So is minus 5 greater than equal to 0 or lesser than 0? Obviously, it's lesser than 0. So in that case, we're going to be looking into this part of the definition. So when x is less than equal to 0, the absolute value of x is equal to minus x. So x in this case is minus 5, right? So the absolute value of minus 5 is just equal to minus x, and we know that this x over here is equal to minus 5, so that is just equal to minus, and x itself is minus 5, so minus and minus is going to give you plus, so it becomes 5. So again, this just proves that the absolute value gets rid of the negative sign. But I just did this couple of examples so that you can get familiar with this definition, because we're going to use this almost a lot of times. Okay, so let's look at this rather simple example that asks us to find the one-sided limit as x approaches 5 from the right-hand side of the absolute value of x minus 2. So what would the absolute value of x be in this case when we're approaching 5 from the right-hand side? So we know the definition of the absolute value of x as x if x is greater than or equal to 0, or minus x if x is less than 0. So in this case, we're approaching 5 from the right-hand side. So just imagine a number line over here. So this is your 0, and you have your 5 somewhere here. So we are approaching 5 from the right-hand side. So we are approaching 5 in this direction. So our x value is a number that is, in the slightest terms, greater than 5. Think of it as 5.1. But that x value, is it greater than 0 or lesser than 0? So obviously, right, if we are approaching 5 from the right-hand side, our x value is slightly greater than 5. If a number is greater than 5, then definitely it's greater than 0, right? It only makes sense. So that means that we're going to look into this part of the absolute value definition. So when the limit as x approaches 5 from the right, so this absolute value of 5 in this case is just going to equal 5, right? because the absolute value of x is equal to x when x is greater than or equal to 0. So in this case, the absolute value of 5 from the right hand side is just equal to 5. So that is just going to give you 5 minus 2, and therefore this limit evaluates to 3. Now let's look at two other examples. So this is asking us to find the limit as x approaches negative 2 from the right hand side and as x approaches negative 2 from the left hand side of the function absolute value of x minus 2. So again, your best way forward is to always define the absolute value first. So the absolute value of x we know is equal to x if x is greater than or equal to 0, or it may also be equal to minus x if x is less than 0. So let's do the first question first, okay? So when we are approaching negative 2 from the right hand side, so that means it's a number that is slightly greater than minus 2. So again, visualize a number line. So you have your 0 over here, you have minus 1, and you have minus 2. So we are approaching minus 2 from the right hand side, meaning in this direction. So the x value, think of it as a number slightly greater than minus 2. So maybe minus 1.9. So in this case, what is the absolute value of that number going to be? So I'm saying, what is the absolute value of minus 2 going to be in this case? So in this case, we're approaching minus 2 from the right hand side. So that means that our x value is a number that is slightly greater than minus 2. So we say that, think of it as minus 1.9. But minus 1.9 is still less than 0. So in this case, we are going to be looking into this side of the definition. So in this case, the absolute value of minus 2 is going to be equal to minus 2, which is just going to be plus 2. Obviously, this is very simple, and we know that the absolute value just gets rid of the negative sign. So straight away, when you have absolute value of minus 2, it's just going to be plus 2. But the only reason I'm doing this is because these are very simple examples. The examples we'll do later on in this video really need you to know this definition. That's why I'm trying to use the definition. So yeah, just make sure you understand what we're doing. So in this case, we know that this absolute value is equal to 2. So we can simply just evaluate this limit as x approaches minus 2 from the right hand side to be equal to 2 minus 2, and that just gives you 0. So this limit is equal to 0. Now let's look at the other example. Same function, same thing, but just that now we are approaching minus 2 from the left hand side. Okay, so you have 0 over here, you have your minus 1, and you have your minus 2 in your number line. But you're approaching minus 2 from the left hand side, so you're approaching minus 2 from this direction. So in this case, your x value is slightly lesser than minus 2. So you can think of the x value to be like minus 2.1. But again, minus 2.1 is lesser than 0. So again, even for this question, we're going to be looking into this side of the absolute value definition. So again, in this case, the limit as x approaches minus 2 from the left hand side is just going to be equal to 2 minus 2, which is going to be equal to 0. So the main thing to take from this example is that it's very possible that sometimes you're approaching a number. In this case, we approach minus 2 from both the right hand side and the left hand side. But in both the cases, we only looked at one side of the absolute value definition. So again, just wanted to reiterate that as you saw in this example, regardless of whether you're approaching minus 2 from the right hand side or the left hand side, the absolute value of this x, right, is just going to be the same value, right? It doesn't really matter regardless of whether we're approaching from the right hand side or from the left hand side. Okay, so let's try and solve this example. So this is the limit as x approaches 5 of x squared minus 25 divided by absolute value of x minus 5. So as usual, we should try and plug in first. So that gives us 25 minus 25 divided by the absolute value of 5 is just 5. So that is just going to be 5 minus 5. So this is just 0 over 0, which is indeterminate. So what can we do over here to get rid of the indeterminate form? Okay, so we know that the numerator is a difference of two squares. So I can write x squared minus 25 as x squared minus 5 squared, which can be written as x plus 5 times x minus 5. But that really does not, get rid of the indeterminate answer. It doesn't simplify the function. So that's when the absolute value comes into place. So one thing I would like you guys to understand is that when we have absolute values, the absolute value can be equal to positive x or can also be equal to negative x, depending on whether if x is greater than or lesser than equal to 0. So that is why when we have absolute values, right, you should always try and do one-sided limits. in order to know that, in order to be certain that your answer is the correct one. Because here we are not told to find one-sided limits. We are told to find the overall limit as x approaches 5. So recall that the overall limit as x approaches any particular number only exists if the one-sided limits exist and provided that they're equal to each other. So in this case, your best way forward is to evaluate the limit as x approaches 5 from the right-hand side of the function and the limit as x approaches 5 from the left of the same function. If these two equal to each other, then we know that the overall limit exists. So let's try and do this part first. So the limit as x approaches 5 from the right hand side of x plus 5 times x minus 5 divided by the absolute value of x minus 5. So when we are approaching 5 from the right hand side, that means that it's a number that's slightly greater than 5. If the number is slightly greater than 5, what does that mean? It's greater than 0, right? Greater than or equal to 0. So in that case, the absolute value of x is going to be equal to the same x, right? So here we can rewrite this as the limit as x approaches 5 from the right hand side as x plus 5 times x minus 5 divided by x minus 5. So now this and this will cancel out, and that leaves us with x plus 5. So that is just 5 plus 5, which gives you 10. Now the same thing for the left hand side. So the limit as x approaches 5 from the left hand side of x plus 5 times x minus 5 divided by the absolute value of x minus 5. So we are approaching 5 from the left hand side. So that means it's a number that's slightly lesser than 5. Even though it's a number that's slightly lesser than 5, that is still going to be greater than or equal to 0, right? So in that case, the absolute value of x is just going to equal x. So even here, we are going to have the limit as x approaches 5 from the left hand side to be x plus 5 times x minus 5 divided by the absolute value of x. We say this is just equal to x in this case, so divided by x minus 5. This and this will cancel. That gives us x plus 5. And now if we plug in, we're going to get 5 plus 5, which is just going to be equal to 10. Now since the one-sided limits equal to each other, we can say that the overall limit as x approaches 5 of our function is equal to 10. Hence, the key takeaway from this example was the fact that whenever we have absolute values, although it might take a few seconds more, try to evaluate one-sided limits, because as we will see in the next example, the absolute value can take different forms depending on whether we are approaching a number from the left-hand side or the right-hand side. So your safest bet, I know it'll take like 10, 15 or 20 seconds more, is to evaluate one-sided limits. In this case, there wasn't any problem, right? Because we saw that we approached 5 from the right-hand side, the absolute value of x was equal to x. But even when we approached 5 from the left-hand side, the absolute value of x was also equal to x. It really didn't matter. We had the same answer, right? Whether we approach 5 from the right or from the left, the absolute value of x was just equal to positive x in this case. But that's not always going to be the case. That's why your best bet is to make sure that when you have absolute values, try to evaluate one-sided limits. Even though they've told you to find the overall limit, always try to evaluate one-sided limits with absolute values. Okay, so this example asks us to find the limit as x approaches 3 of the absolute value of x minus 3 divided by 4x minus 12. So straight away we can plug in, and this is going to be the absolute value of 3 minus 3 divided by 4 times 3, 12 minus 12. So the absolute value of 0 is just 0. So this just gives us 0 over 0, which is an indeterminate form. So can we simplify, factor, or do anything as such in this case? We know the denominator can be factored to, so we can factor 4x minus 12 to 4x minus 3, right? But that really does not help us simplify a function and get rid of the indeterminate sign. So that means that we now need to work with the absolute value. So you might be wondering that so far we only dealt with the absolute value of x, right? X by itself. And we say that this was equal to positive x if x was greater than or equal to 0, or it was minus x if x was less than 0. So now, how on earth are we supposed to find the absolute value of something more complex, right? It's no longer just x by itself. Now we have absolute value of x minus 3. So this is pretty simple. In order to find the absolute value of x minus 3, we literally need to do the same thing as the absolute value of x. But now, instead of x, you just write x minus 3 wherever you had an x. So wherever I had an x over here, instead of just writing x, I'm going to write x minus 3 and copy everything else as the way it is. Okay, so now this, the absolute value of x minus 3 is going to be x minus 3. So I had an x here. Instead of the x, I wrote x minus 3. If x minus 3 is greater than or equal to 0, so again I had an x here, I wrote x minus 3 instead of this, or the absolute value of x minus 3 is going to equal to minus x minus 3 if x minus 3 is less than 0. So again, see, there was an x here, I wrote an x minus 3 instead of the x. There was a negative sign, I copied it as it is. It's pretty important, the negative sign. And then here we just had an x, so I just wrote our x minus 3 in place of the x. Now as you will notice, this is like an inequality, right? So we can kind of simplify it further. We can say that the absolute value of x minus 3 is equal to x minus 3 if x is greater than or equal to 3, or the absolute value of x minus 3 is equal to minus x minus 3 if x is now less than 3. So I just solved this inequalities and I just moved 3 to the other side. So that basically gives me this. So finally, I know that this is the definition of the absolute value for x minus 3. So whenever x is greater than or equal to 3, the absolute value of x minus 3 is just going to be x minus 3. Whenever x is less than 3, the absolute value of x minus 3 is going to be minus x minus 3. Again, this negative sign is pretty important, and there is a bracket over there, so that means the negative sign applies to everything inside the bracket. So we had to find the limit as x approaches 3, and we had an absolute value. So as I just mentioned a few minutes ago, your best bet is to find one-sided limits simply because there is absolute values. So first we'll try to find the limit as x approaches 3 from the right hand side. So let's try and find the limit as x approaches 3 from the right hand side of the absolute value of x minus 3 divided by, I just factored this out, so 4x minus 3. So in this case, we are approaching 3 from the right hand side, so that means that x is a number that is slightly greater than 3. Now if x is a number that's slightly greater than 3, which part of the absolute value definition should we be looking at? This part or this part? So we say that we're approaching 3 from the right hand side, so that means that x is slightly greater than 3, right? So we're going to be looking into this side when we are finding the limit as x approaches 3 from the right hand side. So that means that when we are approaching 3 from the right hand side, the absolute value of x minus 3 is just equal to x minus 3. Okay, so we can rewrite this as the limit as x approaches 3 from the right hand side. We know that the absolute value of x minus 3 when x is approaching 3 from the right hand side is just x minus 3. So I'll just write this as x minus 3 divided by 4 multiplied by x minus 3. So now this and this will cancel, and that just leaves us with 1 over 4. So that means that the limit as x approaches 3 from the right hand side is simply 1 over 4. Now let's try and do the same for the left hand side. So the limit as x approaches 3 from the left hand side, absolute value of x minus 3 divided by 4x minus 3. So when we approach 3 from the left hand side, that means it's a number that's slightly lesser than 3. So in that case, pretty obvious, we're going to look into this side of the absolute value definition, because approaching from the left hand side, so it means a number that is slightly lesser than 3. So in this case, the absolute value of x minus 3 is equal to negative x minus 3. So we can rewrite this as the limit as x approaches 3 from the left hand side. So now I know that the absolute value of x minus 3 is negative x minus 3. Right, so I'll write it that way, divided by 4 multiplied by x minus 3. So now this and this will cancel out, and that now gives me minus 1 over 4. So in this case, the one-sided limits exist. So the limit as x approaches 3 from the right is 1 over 4. The limit as x approaches 3 from the left is negative 1 over 4. But the one-sided limits do not equal to each other. So what does that mean? So that means that the overall limit as x approaches 3 of our function does not exist, since the one-sided limits do not equal each other. So this is why I put an emphasis into always trying to find one-sided limits when you have absolute values. So as you saw, when we approached 3 from the right hand side, the absolute value was a positive number, but here when we approach 3 from the left hand side, the absolute value became a negative number. So that is why, you should always try and calculate one-sided limits with absolute values. Okay, so let's try and solve this final question for this video. So this is the limit as x approaches 1 of x squared minus 1 divided by the absolute value of x minus 1. So first things first is we're going to try and plug in. So if you plug in, so 1 square is just 1, so that gives you 1 minus 1 divided by 1 minus 1 is 0, so the absolute value of 0. So this is just 0 divided by 0, and again this is an indeterminate answer. So what can we do in this case? This might not seem pretty obvious, and this is a very common case of x square minus 1. So remember that 1 can also be written as 1 square. So x square minus 1 can be written as x square minus 1 square. So this then becomes a difference of 2 squares. So this here is kind of a tricky bit, and students kind of tend to overlook it. But the more you practice, the more it will be easier for you to catch this. So x square minus 1 can be written as x plus 1 times x minus 1. But again, that does not help us get rid of the indeterminate answer. So that means that now we need to address the absolute value. So just like how we did in the previous example, now let's try and define the absolute value of x minus 1. So the absolute value of x minus 1 is gonna be x minus 1 if x minus 1 is greater than or equal to 0. So I can now simplify this inequality, and I can say that the absolute value of x minus 1 is equal to x minus 1 if x is greater than or equal to 1. So I just brought 1 to the other side. Or the absolute value of x minus 1 is equal to minus x minus 1 if x minus 1 is less than 0. Again, we can go ahead and simplify this inequality. So then we can say that the absolute value of x minus 1 can also be equal to minus x minus 1 if x is less than 1. So eventually, at the end, this is the part where you focus on, okay? So you just kind of tend to forget all the working we did over here. Yeah, so now let's move ahead. So if you guys recall, I also said that when you're given absolute values, try and find one-sided limits. So in this case, although we are told to find the overall limit as x approaches 1, we should try and find the one-sided limits. So now the limit as x approaches 1 from the right-hand side of x plus 1 times x minus 1 divided by the absolute value of x minus 1. So when we approach 1 from the right hand side, so if you have your number line here, so this is 0 and this is 1. So we are approaching 1 from the right hand side. So that means that the x value is slightly greater than 1. So if the x value is slightly greater than 1, what is the absolute value of x minus 1 going to be equal to? Is it equal to this part here or this part here? So we know that since we're approaching 1 from the right hand side, the x value is slightly greater than 1. So that means that in that case, the absolute value of x minus 1 is equal to just x minus 1. So now we know that this absolute value is just equal to x minus 1. Okay, so now I can rewrite this as the limit as x approaches 1 from the right to be x plus 1 times x minus 1. And I know that the absolute value of x minus 1 is just x minus 1. So I'll just write x minus 1 down here. This and this will cancel out, and that leaves me with that leaves us with x plus 1. So if I plug in, I'm just going to get 1 plus 1, which is going to give me 2. So that is it for the right hand limit. Now let's go and do the same thing for the left hand limit. So the limit as x approaches 1 from the left hand side of x plus 1 times x minus 1 divided by the absolute value of x minus 1. So as we approach 1 from the left hand side, what does that mean? So again, we have our number line here, and as we approach 1 from the left hand side, so this means we are approaching in this direction. So that means that the x value is a number that is slightly, in the slightest terms, lesser than 1. So if x is slightly lesser than 1, that means that we're going to look into this part of the definition. So in this case, the absolute value of x minus 1 is going to be equal to negative x minus 1. So now I can rewrite this one-sided limit as the limit as x approaches 1 from the left to be equal to x plus 1 times x minus 1 divided by the absolute value of x minus 1, which we know as x approaches 1 from the left hand side is going to be equal to minus x minus 1. So minus x minus 1. This and this will cancel out, and that leaves us with x plus 1 divided by minus 1. Don't forget this negative sign. So now if you plug in, you're going to get negative 2. So again, in this case, the one-sided limits individually exist, but the one-sided limits are not equal to each other. So that means that the overall limit as x approaches 1 does not exist. So that is the overall essence of finding one-sided limits whenever you have absolute values. So as you saw, when we approach 1 from the right-hand side, the absolute value of x minus 1 gave us positive x minus 1. But when we approach 1 from the left hand side, the absolute value of x minus 1 gave us a negative x minus 1. So in this case, overall, we can say that the limit as x approaches 1 of our function does not exist, as the one-sided limits do not equal each other.